Okay, happy CircuitPython Day, everyone.
Yay! Blinka, blinka, blinka.
Hey.
All right, we're here with Lady Ada, Scott, and me.
And blinka.
Today, this is part 2 of our special CircuitPython Day broadcast. We have Scott here, and we're going to talk about...
I want to bring the blinka over.
No, Blinka's over there. We have a Blinka up on the screen
yes,
there. Yeah,
it's right
Yeah, we
there.
do.
we were going to talk about the history of CircuitPython. And you did a talk too.
I did.
About this. So let's quickly do intros again. This might be the first time someone's watching
Sure.
one of these videos. Lydia.
Me, Lady Ada. I'm a lead engineer and hardware designer here at Adafruit, which is where we're broadcasting from. This is our factory in Manhattan.
I'm Scott. I'm project lead on CircuitPython. Worked for Adafruit for 3 years on the project.
All right, I'm managing director, and I make sure these video broadcasts are going out correctly today.
Good work.
So, all right, so let's first start out. You did a talk at PyCon.
Yes.
And this was...
PyCon 2019.
Yeah, this was the Language Summit?
The Language Summit,
And-
which is about 50 of the core devs.
Okay.
So those are the people that work on CPython. And then kind of some few other people from core projects, including alternative implementations of
Okay.
Python.
And for the folks who don't know, like, when they hear Python and when they hear CPython, what's the difference between the two?
CPython is the Python that you typically use on your desktop.
Okay,
Written in C, which is what.
Written in C.
got it.
You could
You
think
never,
of
you never see that part. You never see the C part.
So you could think of Python as the language itself,
Uh-huh.
of the like, what does it actually look like and how does it work, and then CPython is like the canonical implementation of it. It's the one that Guido created when he created Python.
Got it. And when someone says something's Pythonic, they mean it's sticking to Python pretty
Yeah,
closely. Like CircuitPython is very Pythonic.
Right. So Pythonic means that like the way that the language was designed and meant to be used, like the way you're using it matches those goals.
Yeah. So if you learn Python on a desktop system,
Yep.
you can use Python on a microcontroller when you use
Yep.
CircuitPython.
Or
And
vice versa.
And vice versa. Okay. So this talk was what?
So this talk was I applied to go to the Language Summit. It's a private thing. There's not a recording, unfortunately. There is a recap on the blog about it. They had somebody there that did a really good recap. And the idea was that you would have 10 minutes to present and 20 minutes to take questions, actually, from the core devs. And so I was coming into this being like, these are the core influencers for the Python as the language, and a lot of them work on the CPython implementation. And I wanted to get CircuitPython into their brains and blow their minds a little bit about how small these devices actually are and how quickly you can use Python by using one of our devices.
I've seen that experience where seasoned Python engineers
Right.
will look at this and say, like, "Oh my gosh, it's Python on the device that shows up as a USB drive." Like, what?
Yeah.
What? How did I not know about this? You know,
Right, and the
it's-
thing is that like we're all busy. They're core contributors to a very popular project, right? Like third most popular language in the programming language in the entire world,
Well,
right?
Actually, depending on who's keeping track of it now. So
Yep.
it's either number one or it's going to be number one.
Yeah,
or it's
it's
not.
growing.
Yeah, it's
Right.
going so fast.
And so day to day, the last thing they're going to do is look at another implementation of Python.
Yeah.
But here I applied to have this slot that was allocated for them to ideally pay attention to what I was saying.
Okay.
And so this is like, okay, given 10 minutes to a bunch of core Python people, what are you going to tell them?
Okay, so we're going to basically redo this talk right now.
Sure.
Since I was in a video. So I took your slides exactly the way they were. Here's
Okay.
CircuitPython.
Yep.
Here's you.
Yeah, so we did the intro stuff. And I'm a freelance software engineer, so I contract on CircuitPython, and I'm paid to work full-time by Adafruit. I talked a little bit about what Adafruit is. So Adafruit has its roots in Learn Guides. So teaching people how to use the hardware that Adafruit produces is core and key to Adafruit's philosophy. And then I think I left it at that. Like our teaching is core to the philosophy.
Yeah.
And next I did a demo, and I don't actually have it set up.
You can explain what it was.
yeah.
What did you have?
So one of my philosophies is like, I want to get to the demo really early. Like,
Yeah.
I could tell you something like I'm about to tell you, or I could
Yeah.
show you. And for these folks, I wanted to show them how easy it was. So I took a Circuit Playground Express because we gave it to everyone at PyCon. I actually brought 50 with me because
Yeah.
I asked them like, how many people are going to be there? And I was the first person after lunch, so I actually I put it out on the tables with them. So everybody actually had one in their hand at this time. So they're like, look, here's a Circuit Playground Express. I plug it into my laptop. Now you can see that it shows up as a CircuitPy drive. There's code on here, and it's pretty dim, and I want to just make it brighter. And that's typically what I do is I find where you're setting NeoPixel brightness, I edit it with one hand and I Control S, and everybody sees it go brighter.
Yeah.
Right, and that simplicity and that speed just blows people's
That's the demo
mind.
that I do, where I just change one thing and it changes the
Yep.
color of the
Yep.
Circuit Playground device, and maybe I'll show REPL or maybe I'll show something else, but
Right.
that's the first thing, because
Right.
that's so magical if someone just has a coding background.
Yep.
They're just like, oh my gosh, I thought that was impossible to do. Because they probably had a bad experience with electronics in some way.
Yeah, and I also wanted to encourage them as Python developers to start thinking about how they could get quicker into the Python experience on a desktop and things like that
Yeah.
as well.
Okay, so then you probably then talked about
Yeah, so
origins of
so
CircuitPython.
the proposal I made was to give background on CircuitPython, and so I said like, okay, well, we actually started from this other project called MicroPython, created by Damien George in 2013, I believe.
I have a blog post because I confirmed it. So one of the things that I've tried to do during this whole MicroPython, CircuitPython
Right.
experience is work with Damien to support his efforts, but also to help document it.
Right.
And he sent me the timeline
Yep.
of everything. So it was recently the 6th anniversary of MicroPython. He
Yeah.
had some code that he didn't commit. It wasn't really called CircuitPython. Then there was a Kickstarter and then a bunch of other things.
MicroPython, yeah.
Yeah. So
Yeah,
so we have a good
And we helped out with the Kickstarter as well.
Yeah, so we have a for sure timeline from the
Right.
creator, because I thought that was important,
Right.
because if 10 years goes by, you start to like miss
Yeah.
emails and like,
Yep.
where did I put this file?
Yep.
And so it is it's about 6.5 years old right now.
Right. Awesome. So I wanted to give that background and I wanted to give that credit, and I made the point that like a lot of what makes CircuitPython feel like Python was done by Damien in these early days. Like he did a great job of getting Python feeling like MicroPython looking and feeling like Python on these embedded devices.
Yeah, specifically the microbit was one of the things that got MicroPython in
Yeah,
the early days.
that was one of the things that he worked on.
Yeah, and
like
then
he kind
later
of
on-
saved the day.
Yeah, and
Because
then-
they had wanted Python on it, and like the person who had told them originally they couldn't manage to do it.
Yeah.
And, like it was all just happenstance in the UK that like all these people were like literally neighbors.
Yeah.
Yeah,
and
it
made
was
it
like down
work.
the street, like at the pub. They're
And
like,
the BBC, they got out about 1 million of these units,
Yep.
and then later on, Damien started his hardware company, George Robotics,
Right.
and he did a Kickstarter, and I
Yep.
think that's the board that was
Yeah,
one
so
of the
this
first
is the
ones.
original Pi board, and this is how he got funding. Is he did a Kickstarter once, and then he did a second Kickstarter for the ESP 8266, which I think is where you were more involved because he actually had the Feather be the like canonical board for that
Yes.
Kickstarter.
because they're like, they
okay.
need an 8266 board, and we're like, well, we stock them.
Right.
All right, do you want me to
Yep.
keep going?
Yeah, let's keep going.
Okay.
And so when I was approached by Adafruit to work on MicroPython, I knew that Arduino was Adafruit's background, and Adafruit had a playbook in my mind. Like I didn't really know you at the time, but like I knew
We're very open, so
you're very
if
open,
people
and I had
just
been
watch our
following
shows
along.
and like look at the
Yeah.
blog, you can kind of figure out what we do. We kind of do the same thing over and over.
So Adafruit built on the platform of Arduino and made all of these breakout boards with all of these devices and made good documentation and good drivers that was all open source and freely available. And so when we were taking MicroPython and bringing it to this board, was one of the first boards we supported, the Arduino Zero. I knew that when we were laying our foundation, we would have to lay a foundation. Actually, click to the next slide, because this is where we have the breakout. I knew that we would have to have a foundation where we could build drivers that would work across all the devices that this code ended up on.
Yeah, and that's something that MicroPython wasn't really ready for yet.
It wasn't a focus of theirs.
Yeah.
Partly, I think, because Damien's focus is on his hardware.
Yeah.
So, like, the STM32 stuff is definitely the best supported. And they're trying to get to a world where they can have a uniform API across all their devices, but they're not there yet. And so that was one of the, like, key technical things that I knew we needed to do
Yeah.
with our version of MicroPython.
And this is just my observation of watching you work. You did a ton of really challenging, hard, complex things to make it so easy. And that's not the focus of the MicroPython project.
No.
It is more for advanced
Right.
users.
Their audience is different. I don't
Yeah.
even, what's the next slide even say?
I can boost this up a little bit.
Oh, yeah.
Yeah. So
Yeah, so what we would end up with is we would have this model of, like, we're going to have a lot of small libraries that people
Yeah,
can
and
use.
I think I even talked to you and I said, one of the things that was more important was like, you're like, well, what should we implement for CircuitPython? And I was like, well, first off, get a UART or a REPL going.
Right.
And I said digital I/O, and then make sure you can like blink LEDs and read buttons. And then I think a second thing I said was like, we have to then do I2C and SPI because the thing that I was actually struggling with, and I saw very far in the future was, we already had Python libraries. You'll talk about this in a little bit. Python libraries for Raspberry Pi and single board computers. But there were
Right.
more and more single board computers being made. Like the Raspberry Pi was the most popular, but there's like 100 different boards. And I also wanted to make sure that whatever we did hopefully would mesh well with that. So
Right.
it wasn't ending up maintaining two types of
Right.
drivers
Right.
because the mass amount of work that we do here is driver writing.
Right.
And when we do tutorials are really just examples for the drivers, right? Like
Right.
it's we do guides about like basic electronics, but a lot of it is, here's 3 boards that we sell, let's make a project out of them.
Right.
But to do that well, the drivers have to just magically work.
Yeah.
And there was a couple of people who had tried to do like a universal driver library function, but the problem is it was like it would be, Bosch, but they'd only care about their drivers.
Right.
Like each company only worked on their own, and
Right.
none of it was, it was all these little silos, so there was no unification for
Right.
making them all work. Like what would it take to make a hardware API that worked with all of them?
Right. But
And I was like, let's do this ahead of time so we don't regret it later.
But also to your credit, like you had existing Python libraries and you didn't force me when I was laying out those APIs to go with that, right?
Yeah.
Like you gave me the freedom to learn and experiment. And I started with MicroPython's machine API, and as I looked at that, I said, this is actually not what we want. The machine API, in my mind, was designed to mimic or generalize the way that a microcontroller works.
Yeah. How does a timer work? How does a register work?
Yeah, and then you put those pieces together, and I was like, this is not actually what we want. I want to be able to do this thing, and that's what you do, and it doesn't matter
You
how
want
it's
the
actually
result.
implemented.
You want to read an analog ping, or
Right.
you want to send an I2C transaction.
Right.
And actually, that's one of the things that Arduino did very well. It's actually quite powerful. I mean, Arduino has the wire library. Is it perfect? No. But
Right.
it does it well enough that it covers pretty much every
Right.
option out there.
Right.
And it's getting better and better. So it's like, I knew the power of if you did have a good hardware API baseline,
Right.
it would unlock everybody's ability so that Arduino is now ported to like dozens of microcontrollers.
Yep.
And there's the ESP32 and the STM and the SAMD and the AVR, and our drivers actually continue to work. If they're well written, the
Right.
drivers
Yeah,
should
we're-
work from place to place.
We're still the top library contributor for Arduino. Probably always will be. But one of
Yeah.
the things that we did like is when we started working with you is we got a little bit of a do-over with, okay, how could we make it the best possible experience?
Right.
So from not needing an IDE to the way it shows up as a drive and
Yeah.
it just restarts and runs programs, because
I remember Lamore being wary about the auto restart.
yeah,
Like all
It was.
programmers are initially like, why are you automatically doing something for me? Like,
Yeah.
I want control.
And I remember being like a little nervous and thinking like, I'm not sure about it. But then I was like, well, I'll try it. And then I was like, wow, this is like the best thing ever. And then, but the another thing is that you did it in a smart way, to your credit. Like, normally people like auto restart, well, you press reset button. I was like, well, wait a minute, like your USB device disappears, everything freaks
Yep.
out. But the way you did it, it's actually like a soft reset where you maintain the USB state and the drive state. So it's actually this very, like, it's kind of magical.
Right.
Like, it's like people don't realize, like, it seems like it's doing something not very complicated, but anyone who actually knows
That's what
how
I was
like
saying, it's so
USB
complicated
state
behind
machines
the
works are
scenes.
like, wow, this is incredibly complicated to make it look so
So
simple.
two examples
Yeah.
that I remember having the same neurons firing when I tried it for the first time, and I go, oh my gosh, this is so cool. The last time I had the exact same like technology, like trying it first time, was when I went to the keynote in Apple that Apple had when they launched the iPod, and I got to
Do the wheel,
thumb the
yeah.
wheel. I'm just like, oh my gosh. And I was like, this is really cool because I can navigate so much. Like, it just
Yep.
makes so much sense.
And
The-
for those who don't know, it was literally a wheel that
yeah,
moved.
it was a wheel, but it was so much different than interacting with.
Well, it used to be like a little button that you press
tick,
and you
tick, tick,
press
tick,
and you
yeah.
press, but this was
It
so
was like,
much.
and it was so
elegant.
much fun to use. The other time that I had the same exact feeling was when I installed Dropbox when they first started out. I'm like, oh my gosh, finally, I don't have to like set up a weird thing to keep backing up my files. And I'm just like, neat, I just toss it into a folder and it
Right.
just works.
Yeah, that magic is it's very important,
Yeah.
but it's so much. There's so much technology. And I remember when we first heard about Dropbox, I was like, well, that's never going to work. Because how are you going to synchronize? Like it's like you can't do that.
Yeah.
But they figured out how to do it.
Yeah, the entire company at Adafruit was running on my Dropbox account for a while. We're now Dropbox Enterprise and everything, but we only needed one account. I'm just like, this is great. All right, so let's keep moving here.
So, yeah.
So then this happened.
We were talking about Raspberry Pi, and we knew that our goals with CircuitPython were to be CPython compatible. We wanted to ramp people from CircuitPython, like they would learn programming with CircuitPython, but be able to grow into CPython.
I think one of the things
desktop
that,
Python.
yeah, it was the U
on the
time that
Raspberry
killed
Pi.
me because I was using
Drove
MicroPython.
me,
What?
Yeah, it drove me nuts too.
It drove me, and I totally understand why they did it, and I
Yeah.
don't. I mean, this is not to in any way diss MicroPython. It makes total sense why they did it.
Yeah.
But the problem is that I had a blinking LED guide for Raspberry Pi that used time sleep, and then I was like, oh my god, I will have to have 2 versions of every code, and that actually to me, I was like, I just didn't want to do that. I didn't want to have to write every example twice.
And to their credit, they made UTime available as time, but they
Yeah.
also the thing that I was not a fan of was that they would add other stuff to UTime
Yeah.
that wasn't in time, like CPython's time.
yeah.
And so like
It starts diverging.
right, and like my philosophy, if you want people to go from CircuitPython to CPython, is you've got to make sure that everything you provide on a module in CircuitPython is available on that module in CPython.
Yeah.
And if you're adding extra stuff like that, that doesn't work.
Probably have to call it something else. Yeah, I didn't
Yeah,
want to I didn't want to get to a spot where we're telling people, here's how to use time, and then here's how to use UTime. Here's math. Here's UMath.
Yep.
Like it could never end. So okay.
Yeah.
So it sounds like we
So-
got to a point where
So
we
that
want
was
to do
the-
something a
that
little
was
bit different.
prereqs.
So
Yeah.
that means it's time to fork.
Yeah, well, the other thing I like to point out is that like I had already forked, right? Like I forked the moment you asked me to
Yeah.
do it, right? That's when I hit the fork button on GitHub.
So it used to be you'd register a domain name. Now you hit the fork button. That's when
Yeah.
you're like,
Yeah.
I'm
Well,
starting.
MicroPython
Well, this
has
is the
a
so
few
the real
thousand
point.
forks right now.
The real point was when we made the domain name. Like
Yeah.
that was we had a discussion about renaming from Adafruit MicroPython. We did like a couple releases as that.
Yeah,
and they
but
were
then
like,
we
"Look,
actually
we
did-
can't do that."
I thought it would be confusing.
Ustruct and UTime, you actually were like, from 1.0 to 2.0, you're like, I'm changing them back to struct. And so
Right.
we had to, we only had like 10
Yeah.
drivers, so we had to go through and fix them all because we liked using struct in time. And I remember you were like, okay, it's now diverging enough that code is no longer compatible.
Right.
And we wanted to, and people were getting confused. They're like, I'm trying to run your driver in
Yep.
MicroPython,
Yep.
and it's saying no such thing,
Right.
function
We also
or
had a
whatever.
completely different focus.
Yeah.
And that's actually the next slide here.
Yeah. The beginner.
Yeah.
Beginner's mind.
Right, and that's a great term, and I'm totally sold on calling it beginner because it doesn't say anything about how old you are
Yeah.
or what your background is. Right.
It could be you're an expert web developer, but you're a beginner at hardware.
Exactly. Right, and it also embodies the idea that like we're not gearing towards classrooms explicitly. Like by focusing on the beginner, we're benefiting classrooms because they are where beginners tend to go.
Yeah.
There's more beginners than experts.
And we're also
Yeah.
not saying this is only for educators either.
Right. Right.
Because I think that's that's a curriculum
Right.
that you're using state guidelines so someone can pass a test.
Yes.
We want someone to use Python in 5 minutes
Right.
and make something
Right.
blank. That's way different.
And I think by focusing on the beginner, we're finding these things that are these magical moments of like, whoa.
Yeah.
Right,
Like, what do
like-
you mean it just works on a Chromebook? What do
Yeah.
you mean? Yeah. And
Actually, you're also
What
the
do
one
you
who
mean
came,
the
you came
code-
up with the idea of having a QSpy Flash or Spy Flash chip. Remember we were thinking
Yeah.
like we need storage.
I remember.
And we'd actually been using Spy Flash for something else. I think we were talking about having an SD card slot. And then you said, well, what about putting an SPI Flash chip on there? And I
Like
was
the ESP has.
and I was just like,
You know how you hit a good idea with Lamore?
Like-
She lays it out overnight and then
I was
has
like-
a prototype
I was
the
like,
next
"Brr, brr,
day.
brr."
when you wake up and there's a board and we have it coming soon
Yep.
on our show, it's like, well, okay, that's happening.
no, because I was like, so how am I going
There's
to
really
Yeah.
no backing out of
Because
it.
that was the problem
Yep.
we had was like, how do we have space? And you said that, and I was like, oh my god, because I was using those chips on another product, and I was like, I already even stock these.
Yep.
So it was like, it was a done deal. I was like,
Yeah, and that's how you
sold.
got Express.
So
Okay.
2 megabytes, and we had Express.
And so, focus on the beginner.
Yep.
So other things that you did. That
So
I thought
this is focusing on the beginner. One of the challenges, this is actually two things.
Yeah.
One thing is people have trouble getting to their error messages. So if you have a product that has a built-in display, like the Pi Portal, we'll show your errors on there explicitly. And then this is actually also in Spanish. So there are lots of beginners who don't speak English, and we want to try to get their language wherever we can. But we still want to teach them Python. So Python keywords will be in English, although that's an interesting experiment as well. But
Yeah.
I
I
love it
remember
now
we were
because-
talking about this. I sent an email and I'm like, hey, multi-language
Right.
messages. We should do
Because
this. And you
Python supports Unicode.
and you had already said
Or
like,
does
yeah,
not.
like this is
well,
what.
I think the catalyst was Mu. Like
was.
Nicholas did Mu in multiple languages,
Yeah.
and they're like, why isn't
and we
the thing that they're interacting with also doing it?
I think
Yeah,
when
good
he
idea.
was doing Moo, I think it was like, hey, check this out. Maybe we should
Yep.
think about this.
And I think I just dropped everything and I did it right
That's
then.
how you know
Like,
Scott. That's how you know it's a good idea for Scott. You dropped everything.
But it was just
Yeah.
like looking at something because Nicholas Entol, for those who don't know him, he works on he worked on because this is like a kind of a small group of people. He worked
Yep.
on the microbit
Yep.
and a lot of things that people know microbit for.
And
So-
MicroPython.
And so he has Moo. Moo is an easy desktop editor.
Yep.
And he really thinks about the user and beginners. And he was
Right.
a music
Teacher. Yep.
And I really like his approach and philosophy. In fact, he's doing a lot of stuff with us. He's doing HyperCard because it's like a HyperCard-like thing.
Mm-hmm.
But the other part of this is I think the other this is almost one of the more magical things. Oh my gosh, seeing error messages on a screen when you're doing like IoT stuff or anything.
Yeah.
So you added terminal.
Yep.
That's this right here.
And this is
Yep.
new. This was something that MicroPython doesn't have.
No.
Yeah, this is and this is built into the core with Display I/O. So
Yeah,
it's
so you
like-
have to play the same trick. So just like USB, like it has to last across
Yeah.
you actually running. your
Yeah,
phone.
it's
And
very
that was,
it's very clever. 'Cause
it
It's funny.
made
like
the
your code-
display stuff take a while, but it was
yeah.
worth it.
Like you
Right.
can create the display in your code, and then after that 3 lines runs, the terminal pops up, and you have
Yep.
it's just like so weird if you're not, if you're a developer from compiled languages, it's kind of
And so we're all about
Configured.
USB, but there's also some other things.
Yeah, this is the future. Bluetooth. I just snagged this off the store, but I wanted to talk, like, we're running out of time. We have a time constraint if you don't realize we're rushing. But the gist is that people who are growing up with computers today do not start with a laptop or keyboard. They start on a mobile device.
yeah. They get a phone from their
My
parents.
nieces, they get a hand-me-down phone, and if we want to get them into programming, we have to have a story on how they can code from their phone. And that is what the next year is going to be.
But that also it has twofold. One, yes, younger people or people who are in developing countries who don't have laptops
Right.
and computers. There's accessibility. Some mobile phones have better accessibility than
Yep.
laptops. It also means that people can work on their projects anywhere. Almost
Right.
everybody always has a mobile device on them.
Right.
So it's like if you want to debug or work on a product, it's like you don't need to have specialized laptops and tools. It's like you could pull out your phone,
Yeah.
pair it with securely, and then work on it.
That's the thing with focusing on the beginner or accessibility features as well, is it always benefits everyone.
Yeah.
Like, you can focus on it, but like, you're not a beginner and you benefit from the auto reload, right?
Yeah.
Like
I love
those
it.
things that
I
I
love the
did to
terminal.
design it. Yeah.
It's great. I debug my code, and then like as I'm developing stuff, I can
Yeah.
actually
You don't even
watch
have
it.
to pull the window up.
Yeah.
You could just look at the device.
Or it's people like, oh, why is this working? And I can see, oh, I see, the SSID password didn't match because it threw an exception.
And
Yep.
for, part of Adafruit is we have full-time support engineers. They're able to help diagnose what's going on, because even if you don't speak English, you can figure out the errors on your CircuitPython device, and that'll help us troubleshoot
Yeah.
it. So it's all those things that independently, it's like, oh, that's neat, that's clever, but when you put it all together, and now upcoming mobile devices. So right now, here's what we're working on. iOS 13 beta now works with CircuitPython drives.
So
There's
USB editing.
USB editing for sure. We have the NRF 52840 and the Playground Bluefruit Express is going to be like our
Yep.
flagship board.
Yep.
And so that'll get us in iOS, Chromebook, anything that's Bluetoothable.
Right.
You'll be able to use it, and it
Primarily focused on mobile.
yeah
So Chromebooks I would do later
yeah
because
And
they can do USB.
they can do USB. Schools, when we talk to the New York City school system is so big. The statistic is something like when school's going on, like 1 out of 10 children are in the New York City school system because there's so many kids. When we talked to the teachers there, they wanted something that had like LEDs and sensors. Can't download software though.
Yep.
Also, like everybody uses Python, so they went through this list. And by the way, can you make it like $20-something? And here we are.
Yep.
And the next thing that's going to be needed is mobile, because some schools only have tablets,
Right.
and some kids only have phones.
Yep.
We do see some like Alpha Geek evidence that's already happening. So people are going to DEF CON, and a lot of people are bringing only their phone, and they have a CircuitPython powered badge, and they can they don't even need a laptop. So we're getting very close already. So that's your talk. That's the thing that you
That's
did.
the talk.
Yay.
Yeah.
So
Got
good
some good
work.
questions, and you can look at the blog post for a
Yeah.
recap of those.
That's your Twitter handle, Tanny.
Yep. People can email me
Yep. And CircuitPython.
and circuitpython.org.
Okay.
Okay.
So other future stuff that we want to do, go into more chips.
Yes.
So
More chips.
More platforms.
We're
Yeah.
starting to look at STM32 with the Teeny USB port to start. We're really
Yeah.
excited about the RT 1062. The TC4 just came
Yeah.
out. It is the fastest, cheapest chip. ESP32S2, which is coming out
Has
in a
USB
couple
support?
months maybe,
Yeah.
has USB support
Yeah.
and Wi-Fi. So
Yeah.
then we'll have a USB Bluetooth chip, the 840, ESP Wi-Fi, ESP32 for USB Wi-Fi, and then the RT 1062 for like ultra fast.
High-speed USB.
High speed,
Yeah.
high speed everything.
That's what I want.
Well,
High-speed USB.
It's also got like built-in graphics controller, so you can just
Yeah.
control gigantic displays, which will be
Yep.
super cool because I feel like you can do a lot with the UI stuff you've been working on, and like
Yeah.
there's a limit to how big the 8-bit displays get. Like they're
Right.
actually they don't get bigger than 320 by 480.
Right.
You
Right.
need to get a TFT driver for the next step up.
Okay.
Lots of exciting things.
Yay.
So thanks for being part of CircuitPython Day.
Thanks for having
It
me.
worked out great. We had all over the videos yesterday. We had a video with Katney,
Mm-hmm.
and now this historic video about the history of CircuitPython.
Right.
Yeah, we're also doing a lot of networking this year with Wi-Fi,
Yeah.
Bluetooth. But yeah, more and more is coming, and it's amazing. It's only been really 2 years of solid CircuitPython development,
Yeah.
and we, building on MicroPython, we've come so far. Like we're able to do stuff now that took a decade with other microcontroller platforms. It just the
Yeah.
evolution of the code and structure, but we've learned from all of them. Like I feel like we're not
Yeah.
making the same mistakes, which I think is like
Yay.
really cool.
Yeah, I think everyone
new
des-
mistakes.
Yeah, I think everyone deserves
that's
to
okay.
make new and interesting mistakes
Yeah.
instead of the same ones over and over.
Yeah.
Yep.
Okay.
So
All right.
that's
Well,
what's
thanks
coming up.
everybody.
Thank you.
And that is our
Join Discord if you want to keep chatting about
Yeah.
CircuitPython.
Always happy to chat.
and that is our CircuitPython Day. Bye everybody.
Blinka blinka.